Hi, I'm Professor Srinath Ekkad, and I'm going to give you a short lecture on how an internal combustion engine works. First, we're going to all the important aspects of the cycle of an internal combustion engine, and then we're going to look at how the hardware looks like in respect to what we see on this short presentation. So first, I'm showing you is four-cylinder engine. Each of them has a different cycle. And basically, this is how the real car engine works, where all four engines are working in tandem to produce continuous power. So as you can see, when it becomes dark red is when the combustion occurs, and when it comes back down is when the power stroke occurs. So we will now look at all the important features of the cycle. The first thing I want to show you are various definitions that go along with a typical piston cylinder device. So what we have here is a cylinder and a piston, and we have two valves. One is called the intake manifold, and the other one is the exhaust valve, and both are connected to the cam, through the cam to the crankshaft. The crankshaft is basically when the piston goes up and down. This rotates, and basically these two valves are timed by attaching to the same device, so they will open at the same time when the piston is at the right spot inside the cylinder. So if you look at that, there's what is called the bore, is the diameter of our cylinder, and what you see is the piston, which goes up and down, and we have an intake valve and an exhaust valve. When the piston goes all the way up to the top, which is called the top dead center, TDC, then there will be the minimum volume area, minimum volume inside the cylinder. When it comes back all the way down, you can see is the bottom dead center, where the stroke finishes, and the top to bottom difference between the bottom dead center and the top dead center is called the stroke. So the displacement volume is the difference in the volumes, and the clearance volume is the minimum volume that is present inside the piston when inside the cylinder when the piston reaches the top. So now let's look at the various features of the cycle. First, what happens is when the flow is coming in mixed with the fuel, you have the intake stroke, which is when the intake valve is opened and the air rushes into the cylinder and pushes the piston down. As you can see, the air-fuel mixture is coming in and it's going, whereas the exhaust valve is closed. So the air comes in, pushes it all the way down to the bottom dead center, and during that process, the crankshaft rotates and pushes the piston down, and it's just the 1/4 of the rotation of a full cycle for the crankshaft. So at this point, the exhaust valve is completely closed and the intake valve is fully open, and all the way you can see the fuel air mixture coming in. And at this point, they were at a low pressure. So when it reaches at the bottom, the crankshaft has nowhere to go because it's already in rotation. It's going to move forward and continue to rotate. And in that case, the piston will end up moving back towards the top dead center, which is this way. But at that point, because of the pressure difference, the intake valve also closes. The exhaust valve remains open. The exhaust valve remains closed. So the leftover, the air which is inside the piston cylinder is going to get pushed up all the way up into the top dead center area, which is the minimum volume, that is the clearance volume. So at this point is at very high pressure, and then we move on to the next part of the cycle, where when this high pressure air comes in contact with what is called the spark plug right here, the spark plug is ignited, and this air fuel mixture combusts and produces high energy, and it's called rapid combustion because it goes very fast within a few milliseconds. And then because of this high energy of the fuel and both the valves being closed, the air doesn't have any other place but to expand in this direction, pushing the piston downwards towards the bottom of the center, and that's called the power stroke because it's an expansion of the fuel air mixture down towards all the way to the bottom, so it completes another quarter of your crankshaft. So now all this air has pushed all the way down to the bottom, and when it reaches the bottom dead center, the pressure lost. So the air that was inside such a small area is now expanded all the way to the big area, so the overall pressure decreases, and the piston reaches the bottom dead center. At this point, the air doesn't have anywhere to expand further because the piston has reached the bottom here, and the crankshaft has completed a full rotation, and it has nowhere to go again, and it starts turning back. And in this case, what happens is the air starts getting pushed out, but at this point, because of the cam connections to the crankshaft, the exhaust valve opens, and the spent air fuel mixture is going to come out and lead through the exhaust valve. So this is basically the four aspects of the cycle. We got the intake, the compression, the combustion, and then the exhaust. So all four constitute one stroke. That's why it's called a four-stroke engine. And if you look at the whole process, what you see is top dead center, bottom dead center. This is the Vmin, Vmax, and this is the exhaust pressure, minimum exhaust pressure. And this is the area of work that you're getting in a thermodynamic cycle. So if you look at breaking it down into more simpler aspects, we got one, which is where the bottom dead center is, and then it moves isentropically compressed to top dead center, and then you add the fuel air mixture and ignite it, and then you got this the higher temperature, high pressure air here, which expands further down isentropically, reaches 4, and then it's exhausted, and you lose the heat through the exhaust. It's called a closed cycle because we assume that the air that's coming out is recycled back at low temperature. But in reality, it doesn't happen because whatever air comes into your engine is actually exhausted at the back of your tailpipe. So you basically have what is called an open cycle. So basically, the air that's coming in at 1 is not the same as air leaving at 4. So you get an open-ended cycle. And in reality, this is what happens to the engine also, because it's not got sharp corners like here where it reaches a certain pressure and turns immediately. So if you see the real cycle, you've got a little bit more complex things going on where the ignition occurs here, the end of combustion occurs here, the expansion occurs here. This is where the exhaust valve opens and its intake valve opens, and then you get intake and compression. So it's a little bit more complicated than what happens in a simplistic thermodynamic cycle, but this cycle here explains what we really saw on all aspects of the four strokes of the engine. Here is one cylinder, 4-stroke engine, typically used in a lawnmower at our homes. And what I am going to take off is the bulkhead at the top, which has got the spark plug right here at the top, which is on the other side is the spark which is going into the cylinder. And you've got 2 bolts here which take off. And then this is the crankshaft, which is connected to the drivetrain, and there's a shaft here which connects to the actual the motor with the wheels. So if I take off the top part of it and I show you, this is where the clearance volume is right here, and there's the spark igniter right here, and this is the electrical connection that goes in from your battery. If you see your 2 valves, one is the intake and one is the exhaust, and we have the cylinder and the piston. So if you also see that the valves are connected to the cylinder through a cam shaft, which actually a spring device which connected to the crankshaft, which helps rotate the valves at the right time. So now if I start off, this is my top dead center right here, and my exhaust valve is completely open. That means all the air fuel mixture that's going out is all exiting through this exhaust valve. So now I'm going to go down and reach, see the inlet valve is completely open, and the air comes in and it completely fills up the cylinder. And at this point, now when you continue rotating the device, now it's going to compress the gas fuel mixture and reaches the top dead center at this point. And at this point, the spark plug would ignite the air fuel mixture right here. And then that will cause an increase in temperature pressure, and which will push the piston all the way down. keep going down till it reaches the bottom dead center. At this point, this is called the power stroke or the expansion stroke. And once it reaches the bottom dead center, the gas has completely expanded and it has nowhere to go. So at this point, the crankshaft is still rotating. So it's going to start pushing the exhaust air out, and the cam will then open the exhaust valve, and the exhaust valve will release all the gases out and back to the tailpipe of your car. So these are the 4 strokes of the engine, and all the 4 strokes are controlled by the rotation of the crankshaft and the cam, which controls the valves.